Problem 4. In the equations shown on the screen, the letters A, B, C, D, and E represent different base 10 digits. So the right-hand side is a 16-digit number, and AA is a 2-digit number. Given that C equals 9, find A, B, D, and E. So let's start by getting a feel for how big A is. And it's a useful fact to know, not just for BMO, but in life, that 2 to the 10 is equal to 1024. And we're going to use this to investigate the possibilities for A. Let's start by thinking about how big 2 to the 22 is. Well, 2 to the 22 is equal to 2 squared times 2 to the 10 squared. And that's about 4 million. Now, this is an underestimate here. Nevertheless, this is quite a bit smaller than the right-hand side up here, and so A is not going to be 2. We can also use this fact to investigate whether A could possibly be 4. So 4 to the 44 is equal to 2 squared to the 44, which is equal to 2 to the 88. 2 to the 88, sorry, 2 to the 8 times 2 to the 10 to the power of 8, which is going to be greater than or equal to 10 cubed to the power of 8, which is 10 to the 24. And we've got something much too big. So A has to be strictly between 2 and 4, and we know that A is 3. OK, so we know that A is 3, and this means that the left-hand side is divisible by 3. And so is the right-hand side. So it's quite tempting now to do a digit sum and to say that all of that is divisible by 3. However, because we've got so many letters here, we don't immediately get to an answer that way. And so slightly more efficient to look at the final 2 digits, and we can look at what happens to the final 2 digits of powers of 3 by considering the remainders that they leave when you divide by 100. So let's have a look at this. 3 squared is 9. Now I want to end up at 3 to the 32, and I could go through and multiply this by 3 each time, but that's going to take a very long time, and actually I can get to 3 to the 32 by squaring this. So if I square both sides, I get 3 to the 4 is 81, which is also 81, a remainder of 81 when you divide by 100, obviously. And I can square this again, 3 to the 8, which is going to be 81 times 81. Now, because I'm only interested in the last 2 digits, it doesn't matter what happens here, but I know that it finishes with a 6 and a 1. And I can write that it's congruent to 61 mod 100, which means that when I divide by 100, it leaves a remainder of 61. We can square both sides again to get that 3 to the 16 is congruent to 21 mod 100. So 3 to the 32 is congruent to 41 mod 100. And we've got there, so we need to add on 11. And we get 52. And multiply this by 3. To get 56. And this is brilliant news, because that means our number finishes with the digits 5 and then 6. And that tells us that B must be 5 and E must be 6. We've got 3 digits so far. So we've almost got everything now. We know every letter apart from D, and we can go back to looking at the digit sum, and we'll have something more productive this time. So here, we know that the left-hand side is divisible by 3, which means that our digit sum will be divisible by 3. But 3 clearly goes into the 9 and the 6s, and it also goes into these 9 5s here. So we are left with 3 divides 2D. And that means that 3 must divide D. And so we can think about the possible options for D. It could be 3 or 6 or 9, although it can't be 3 because A already is, and they had to be different digits. And it can't be 6, and it can't be 9, and there's only one option left, and that is that D is 0. And now we have all 4 letters that we were looking for. A is equal to 3, B is equal to 5, E is equal to 6, and D is equal to 0.